So just like we did last week, we're going to write a results section about the basic design and statistics. For the first couple of weeks, we're going to just focus on the results sections here, mostly because the way that we take in information through iLearn, the point allocation, I just want to put the emphasis on the writing of descriptive statistics, inferential statistics, confidence intervals, and effect sizes. So you'll note that the structure of this will look very, very similar to what we had last week. The first thing I want you to do is to describe the results, noting the direction or the difference between the two samples. I need to know what the population mean is in a single sample Z or T test. So this first sentence, much like the null hypothesis, shouldn't feel a whole lot different. I want to report the inferential statistic that I actually used. Last week we used a single sample Z test. This week we'll be using a single sample T test. That we use to compute the p-value. If I know the exact p-value, which I'll get if I do that horrible formula, use a statistical calculator or Jamovi, then I can report it. In our class, if you've done this by hand, you can report what the p-value is equal to if you're in Jamovi or a statistical calculator. But instead, if you're doing it by hand and you're in the rejection or retention region, just say when you're writing it by hand, is it less than or greater than 0.5? But again, importantly to report if the results were statistically significant or not statistically significant. And finally, you want to report and interpret both the 95% confidence interval around the difference between the two means. As you get to start to read more statistics outside of this class, you'll begin to note that, again, sort of the new group of statistics or statisticians really focus a lot of their decision and their interpretation around the 95% confidence interval on the difference between the two means for this particular statistic, as well as the effect size. So let's look at how we could write this up. So again, the first thing we want to do is we want to give the first sentence to be descriptive, to be very similar to the type of information that we would say if we were just telling someone about the study that we did. If we were describing our results in an elevator, we almost always would just talk about the mean, probably the confidence interval, and in this case, the comparison to the general public. So participants who had, so what was the independent variable here? We manipulated their news feeds. All right, so for that particular new group of individuals, they had higher, right? Higher is our word that we use to connote directionality, right? They had a higher percentage of positive emotion words right here. So this is basically the manipulation, which is the IV. This is the direction word, which tells me what happened to the dependent variable, which was the percentage of positive emotion words. So see, I don't say this is my IV, this is my DV, but I can intuit from it what this model ultimately looks like by the way that I wrote this, right? So participants who had their news feeds manipulated had a higher, that's the direction word, percentage of positive emotion words in their post. Here's my mean that I computed from the sample. Here's my standard deviation that I computed from the sample. In this case, they were both given to you, as well as the 95% confidence interval around that. So again, I don't write out, I'm 95% confident that the population mean is no less than 5.27 and no greater than 5.31, but I'm expecting readers to know that in their head when they read this, right? So they can read this parenthetical statement and go, oh, okay, I can see here this lower limit and this population mu from the general public doesn't overlap. So, I can actually read this first sentence here and begin to intuit that I'm going to reject this null hypothesis, meaning that it's going to be a statistically significant result. Now I write my inferential statement, right? So I used a single sample t-test, right? I have to say the statistic that I used, and that demonstrated or showed that there was a difference between the two means that was statistically significant. In the lab this week, we'll actually talk about that when it's not statistically significant, all we write here is that the mean difference was not significant. That'll be one of our changes. In this case, we have the t with the degrees of freedom, the observed value that I actually got in step number 3, or the observed value that I actually got in step 3 from the computer. If I have the computer, I can actually report the p-value. If I've done this by hand, since I don't have what the p-value actually is, the only thing I know is it's less than 0.5 because it's in the rejection region. It would have been greater than 0.5 if it was in the retention region. I know that the 95% confidence interval around the difference between the two mean also did not include 0, which is more language to say this is a significant result, and or, by the way, I rejected the null hypothesis. Oh, typo here. I will correct this on the slide. This should be 0.03 to 0.0. Oh, nope, sorry. That's actually, yeah, 0.07. I thought it was a typo. So I will correct that on the slides. One of these days, I hope to get through all of these without any typos, but it's hard. Finally, I really want to say that this is an important new sort of way to make sure you write these conclusions. The standardized difference between the two means suggested a trivial treatment difference. And so again, it's a significant difference, but maybe it's not one that I should care so much about. So let's go ahead and change the value here. So there we go. Right, and so we can see that that's what the interpretation should look like. Again, if you remember from last week in the um, APA style conclusions, I really pick certain pieces of information to make sure you know where they're going. A lot of APA style writing is a little formulaic. As you get better at it, you can put your own flair on it. But especially in the beginning, it's important to make sure that you really know what are the most important component pieces. Okay, finish up this lecture by completing the last question in this lesson, and then go ahead and start on the lab when you're ready.